Today we're going to learn about simplifying radicals. A radical is just a name for this root symbol, and the ones that we're going to be working with are square roots. Well, the square root of 1 is 1 because 1 squared, which is really 1 times 1 itself, is equal to 1. The square root of 4 is 2 because 2 squared is 4. The square root of 9 is 3 because 3 squared is 9. Perfect squares like 1, 4, and 9 are perfect squares because the square root is a whole number, not an irrational with a never-ending decimal. Perfect squares are the most important part of today's lesson. So it's time to make a note card. Take out either a note card or a piece of paper that you can fold up and tape the edges, and I want you to write all the perfect squares between 1 and 400. That means you're going to write 1 squared, 2 squared, 3 squared, so on, up to the number 20 being squared, which ends us up at 400. Example 1. What if they asked us to take the square root of 18? Well, the square root of 18 is, if you put it into a calculator, you'd get 4.24264, never ending and never repeating. That means 18 is not a perfect square. But what if there is a perfect square that is a factor of 18? Maybe I could find a way to break it down and simplify further, even though 18 is not a perfect square. So we take a look at the factors of 18, 1, 2, 3, 6, 9, and 18. And we must use only a perfect square and only the largest perfect square. We must use the largest perfect square factor. It has to be a perfect square. So how are we going to use 9? We're going to rewrite root 18 as a product of two separate roots. Root 9 times root 2 is the same as root 18. And root 9 here is a perfect square. Aha! So then we can simplify the perfect square portion and leave the part that we can't simplify, the root 2, as it is. The square root of 9 is 3 times root 2. And in math, if you have a number in front of a radical, it means you're automatically multiplying, so you don't need the dot there. A common error that I see is that students will just pick any factors of 18. We can only use the largest perfect square. So something like square root 6 times square root 3 would not help you whatsoever because neither of those numbers are perfect squares. What if they've given us square root 32? Put in your calculator. It's not a perfect square. 32 is not a perfect square. But what if there's a factor of 32 that's a perfect square? There are 2 factors of 32 that's a perfect square. So which one do we use? We have to use the largest perfect square factor, and that would be 16. So we're going to rewrite root 32 as a product. Root 16 times root 2 is the same as root 32. And I actually know what root 16 is. What is the square root of 16? That's 4. And so this simplifies to be 4 times root 2. So what if you had just decided to use 4? Well, 4 is not the largest perfect square. That is a factor of 32. So you would get the problem wrong. It has to be the largest perfect square factor. So does that mean I'm going to have to write out all the factors of every single number so I can figure out which of the factors is the largest perfect square? No, I'm going to show you how your note card will really help you when simplifying radicals. To begin, we have the square root of 225. So take a look at your note card. We're going to look for where 225 would lie in the perfect squares list. Oh my goodness! 225 actually is in the perfect squares list. 225 is a perfect square, so our answer will just be whatever times itself is 225. And that would be 15. This could also be rewritten, though, as the square root of 15 times the square root of 15, because 15 times 15 is 225, and the square root of 15 times the square root of 15, of course, is itself 15. We're done. Now, that one was definitely pretty easy because it was a perfect square, and the majority of what we're working with is not perfect squares. So, here's our next one, the square root of 40. Take out your note card and see where 40 would lie in the list of perfect squares. So now we want to see if any of the perfect squares that are less than 40 are a factor of 40. You could try 40 divided by 36, but I'm pretty sure you can tell that's not going to go in evenly. You could do 40 divided by 25, but 25 doesn't go into 40, 25 goes into 50. You could try dividing by 16. Oh, does 16 go into 40? You could try dividing by 9. Nope. Let's try dividing by 4. Hey, that one works. Now you may just look at this and say, I could have told you that 4 goes into 40 and then we're done. But the reason why I start with the largest and then go down is because we have to have the largest perfect square factor, not just any perfect square factor. And so oftentimes I know that 4 goes into a number, but I still have to check to make sure that if there's a number that's greater than 4 that goes into it, that's also a perfect square, that's the one I need to use. But the largest perfect square that is a factor of 40 is actually 4. So we're going to rewrite as a product, square root of 4 times, 4 times what gives me 40? That would be 10. Square root of 4 times square root of 10 is equivalent, is the same as square root of 40. Now, after we have rewritten so that our perfect square is in the first radical, I usually like to keep it in that order just for organization's sake. So now the square root of 4 I know is 2, and the square root of 10 I don't know, and so I leave it as the square root of 10. And are there any perfect square factors that go into 10? No. So then you know you have simplified it as far as you can. Square root 108. Let's look on our list of perfect squares. Where does 108 lie? Okay, it's right next to 100. Does 100 go into 108? Not evenly, no. Try the next one, 81. 108 divided by 81? Nope. 81 is not a factor of 108. 64? Nope. 64 also is not a factor of 108. 49? No, 49 is not a factor. 36? 36? 36 times 3 is 108. All right, so we're going to first rewrite this as a product. Root 108 can be rewritten as root 36 times root 3. The square root of 36 is 6. The square root of 3, I don't know what it is, so I'm just going to write square root 3. as long as there is not a perfect square that is a factor of the number inside of the root, then we are done simplifying. Take a look at 48. Now, some of you may think, hey, I know 4 goes into 48, so I'm going to use 4. But we can only use 4 if it's the largest perfect square that goes into 48. So look on your note card to where 48 would fall in the list of perfect squares, and then we'll go in descending order. Does 36 go into 48? Well, you could try 48 divided by 36. Nope. 25 does not go into 48 because it goes into 50. The next one is 16. Does 16 go into 48? Actually, it does. 16 times 3 is 48. Okay, so if we had used 4, we would not get the correct answer because we would have not completely simplified. You have to use the largest perfect square. All right, so we're going to rewrite 48 or root 48 as root 16 times root 3. And simplify. The square root of 16 is simply 4. And we drop the square root that we cannot simplify further. Let's take a look at where 128 lies in the list of perfect squares. And then we'll start with the number closest to 128, that is less than 128. Okay, 128 divided by 121. No, that's going to be a decimal. That's not a factor. It doesn't divide evenly. So let's try 128 divided by 100. No, that's not going to divide evenly. We know 100 goes into things that end in zeros. So 128 divided by 81. No, 128 divided by 64. 64 times 2 is 128. So 64 is the largest perfect square that goes into 128. I will rewrite radical 128. This square root can be called a radical as radical 64 times radical 2 because 64 times 2 is 128. Now we will simplify what is the square root of 64. That is 8. And then we drop the radical that cannot be simplified further. 288. Look at your list of perfect squares and see where 288 would lie. Now you're going to start with the closest perfect square and start dividing using a calculator. Try it out. What is the largest perfect square that goes into 288? And it turns out that 144 times 2 is 288. So the square root of 144 times the square root of 2 is the square root of 288. And now we will simplify. The square root of 144 is 12 times the square root of 2.